on your practice test. But really what I'm going to do, instead of just going through each example and giving you answers, is really just kind of talk about how these graphs are created and the relationship between all of those. All right, so let's get ready for a little bit of motion graphs. Okay, so what are these motion graphs all about? We're going to go through position versus time, velocity versus time, and acceleration versus time. Okay, let's go back to our first day of school. Now, this constant velocity, we're just moving a car down the hallway. So let's take a look here at what that would be. Okay, so I don't know, let's say we got meters we're keeping track of on the y, seconds we're keeping track of on our x. I don't know, after a couple of seconds, let's say it gets to be, about 10 meters or so away. That's moving pretty quick, but well, it just kind of makes for an easier graph. Let's say, all right, then maybe our next mark after 4 seconds gets going a little further, maybe up to 20. Okay, a couple seconds later, here it's 6. Maybe it's going to get up to 30. So really, once again, these same times are going to be on each axis. Oh, geez. Okay. So it's a pretty simple graph where it's just going to be going up. So after 8 seconds, maybe it gets up to like 40. And finally at the end, after like 10 seconds, it's going to get up to, say, 50. All right, now our question is how do we put these dots on our velocity versus time graph? Well, if you look at that, our slope of that, the slope of a position time graph is our change in y, which is position, divided by our change in x, which is time, and that's our definition of velocity. So really all we want to kind of look at is, okay, what is the slope at each spot? So after 2, what is the slope there? Well, it went up 10 over 2. Our slope there is 5. What is the slope at 4 seconds? Well, it went up 20 over 4. That still is 5. What's our slope at 6? Well, it went up 30 over 6. That still is 5. What is our slope at 8? Well, it went up 40 over 8. That still is 5. What's our slope here at 10 at the end? Well, it went up 50 over 5. Our slope is still at plus 5. So the reason it's constant velocity is that slope of our velocity timeline is constant, which really means our velocity is constant. And so keep thinking of these in terms of slopes. So here on our VT graph, where really we were graphing the meters per second, we were graphing the meters per second. Same thing here, we're looking at the slope of this graph, so it's our change in velocity over time. That is our definition of acceleration. That slope is a 0. That slope does not change. So if I wanted to if you look at this, that is meters per second. Our time is seconds. So really we get meters per second per second. Meters per second per second. Now, if that slope here is 0 at each point, then really what I do is say, okay, at 2 the slope is 0. At 4 the slope is 0. At 6 seconds the slope is 0. At 8 seconds the slope is 0. At 10 seconds, the slope is 0. So the slope stays 0. Constant velocity really means 0 slope. So yeah, it would just be right along our axis there. And really what that's saying is just the acceleration is 0. But that is what it means to be constant velocity. Now keep in mind this was moving forwards. All right, and really I guess if you look at that, we define forwards to be positive. So moving in the forward direction, moving in the positive direction at constant velocity. This is what your position time graph would look like. This is what your velocity time graph would look like. And then this is what your acceleration time graph would look like. And that's for constant velocity forwards. All right, let's take a peek at another set of graphs that all kind of go together. And really we're going to try to play that same game. But now this time let's just imagine that we're out in the hallway and we take our car and we are just going to turn it around and have it put, 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 put along and go same speed. But now it's going to go at the same speed, but we're going to turn it around and have it move backwards. So really backwards we're going to say is in that negative direction. So it still has the same markings. It's just like our car got to the end and turned around and went backwards. So we're going to start it here out far away at like 50. So it starts out there and then it's going to just kind of move back and come closer and closer and closer. So maybe here at 2 seconds it's going to get to like 40. Then at, say 4 seconds, it's getting closer. Maybe here at 30. And it's going to get even closer here at 6 seconds. Get to like 20. Then we can say, okay, here at 8 seconds, it's getting even closer. All right, so the idea with this one is that as it gets closer and closer and closer, it is just going to be moving backwards. But let's see here, what is this slope here? So if I wanted to look at this line and think of, okay, what's that slope? Well, once again, our slope is change in position over change in time. But the line's going down. So what is this one here? So it went down 10 over 2. Down 10 over 2, that is a slope of -5. What's my dot here at 4 seconds? This was down 20 and over 4. That's still -5. What is my slope here at 6? Well, it went, what, down 30 over 6. Still is a slope of -5. What's going on here at 8? It went, what, down 40 over 8. Down 40 and over 8. That still is, so yes. So really it's moving at the same speed, just the same speed coming backwards. And once again, what's the slope of that line? Is 0. So our acceleration would be 0. But yes, please, the whole key to these motion graphs is just think about them in terms of slope. And those slopes are our definitions of velocity and our definitions of acceleration. And really those are also the equations, I guess, that we've been using to solve all of our problems. Okay. Now, I guess where this gets trickier is when acceleration's not 0. So let's look at, imagine, yeah, just kind of like, remember our class we did, kind of use our physics book here, and we, if you remember, we used our book to make the little ramp. And so these are usually the ones that give students trouble, are these questions where the velocity is changing. Okay, let's see how we do on this. All right, let's start us off here at 0, 0, and we're going to have this thing coming down the ramp. So here's my marble, and it's going to be at 0, 0 to start with. So I think a good thing to think about is if I'm going to do a position time graph, I'm going to start myself right here at 0, 0. And so I kind of had this set up where it's going to roll down the ramps. Now really what this is a lot bigger than this is more like a bowling ball moving like down a big driveway. So imagine you got a nice long driveway with the incline, and you're just going to let this bowling ball go. All right, so we got 50 meters here. So we're going to start it at 0, 0. Now, depending on the incline, those first few marks, you know, maybe it rolls a little bit down the hill, and maybe that's at about, let's say, 2 seconds there. So at 2 seconds, it's not going very far. But if I wanted to go here to this graph, I would say, okay, here at 2 seconds, it's just barely moving at all. A little bit further away. Then, you know, it's picking up, okay, it's going a little faster, but still not really getting very far. So let's say after 4 seconds, gets to about right there. So here on our graph at 4 seconds, it's still there, but still really not quite up to 10 meters away. Then it's a little bit better, I don't know, maybe just past 10 or so here, and that would be like at 6 seconds. So if I were to try to mark that on my graph, okay, here at 6 seconds, getting up close to right around 10 meters. But then by now it's like, okay, now it's rolling. Now we really got to kind of chase after it. So let's say here, chasing down that bowling ball. Let's say it gets there after about 8 seconds. So I can put that mark on my graph. So here at 8 seconds, it's getting, what is it, almost, you know, past 20 meters. So up here, so getting a lot further away at 8 seconds. And then finally, really, once it's moving now, once it's really flying, then it's it moves the most distance there kind of at the end. So let's take a look here at 10 seconds. At 10 seconds, that bowling ball really kind of picked up speed and got down to the end of your driveway. So here, like how if you were to mark where it was every 2 seconds, this is kind of roughly how that ball would progress down the hill. So let's put this last mark on. Let's say here up at 50, and at 10 seconds it was up to there. So the whole thing is, and if you remember rolling the marbles down the ramp, it's really, and this is, you know, we kind of see this general shape of a curve for something that is when the velocity is increasing, and it's increasing in the positive direction. Now what I'm kind of hoping you're getting better at is looking at this in terms of slopes still. So, but with a curve, really what we're going to look at is the slope of the line's tangent to the curve. If we can look at these tangent lines, that slope of the tangent line, it's still a line on a position time graph. So it still is change in position over change in time. And what we start to call that is the speed or the velocity at that instant. So we call it instantaneous velocity. Okay, so here at this slope here at this tangent line, not great. I mean, it's probably, I don't know, barely moving there at the beginning. At 2, I don't know, what is that slope? It's close to 1. So that slope would be close to 1. Here after a couple of at 4 seconds, so here at 4 seconds, what am I doing looking at that slope there? It's a little higher, but still not much higher, still probably about a slope of 2, maybe, I don't know, up 6 over 4, so still not even really quite to 2. Then at 6 seconds, what is it, up to like 10? So kind of just estimating that slope there. I don't know, is that up 10 over 6? Just estimating it, but still really not, maybe about there, still less than 3 really. So after 8 seconds, let's see here, what do we get? 8 seconds, what's that slope? Well, now it's starting to get a little steeper. Now it's gone like almost 25 and 8, estimating. So yeah, now it's kind of getting up over 3. And then really at the end, that's the steepest slope right there. That one is, up 50. That's one's up, well, just kind of estimating it. It's probably going to be close to 5 or so. So the whole thing with this is as these slope of those tangents increase, so does my velocity. And so I think hopefully we understand that the velocity is increasing when things roll down the ramp. And then really it's the same thing. Keep using that as your way to create the next graph. So your decision here is to look at, okay, let's look at slope. And for this one, it was change in velocity over change in time. This is a positive slope. In fact, what is this slope? It's like, what, up 5 over 10. Up 5 over 10 is the same as up 1 over 2, but it stays the same. What's the slope at that? The slope at each point, that slope remains to be the same value. So it's what we say, the acceleration stays constant, or the rate that the velocity changes stays constant. But please, please, please think of that. And this was also really another kind of hand-drawn graph that we did. But we did this marble graph. And that marble graph is going to have its motion graphs appear like that. Okay, let's get to some trickier ones, but now let's see if I do here. But it's the same thing. It's the marble graph, but really all that we're changing is just where do we stack up our books? Where do we start that incline? So if we change where that incline is, and change how your positions, or just change how you start measuring those positions, then that is how we're going to keep track of where the ball is. So let's roll our bowling ball. Let's do the same thing here. Let's take our bowling ball and let's roll it down the ramp, but this time it's going to roll backwards down the ramp. So we're going to, or our driveway if you want to think of it. So it's going to go at 50 and then get down to 0. So let's say, okay, so here, it barely gets going. So let's say here at 2 seconds is where the ball is going to be. So let's go to our position time graph and say, okay, at 2 seconds, it's still pretty close to 50. But then it's going a little faster, a little faster, a little faster. So I don't know, maybe it gets a little farther. But let's say it's about still not very far. Let's say it gets about there, and that would be like at 4 seconds. So here at 4 seconds, a little bit closer to that 40-meter mark, but not quite there. Okay, then its ball's rolling down the ramp, Okay, I'd say it gets to about here or so, and that's a couple seconds later, so let's say that's close to 6 seconds. If the ball gets there at 6, so here at 6, it's a little, right around that 40 mark again. Now it's going to start picking up a little pace, and so it gets a little more distance behind it. So let's look at it. Oh, I don't know, let's say it gets to be about here, so there's the ball, that's at about 8 seconds. But by now it's really rolling. So here at 8, it's down by that 30 mark. But now it's really kind of moving pretty good at this point. And so it's going to finish off, or really this next couple of seconds, it almost, let's just say it gets down to the bottom of our hill. It's moving faster now than it was earlier. So it really covers that most of its distance in that last little bit. So I can put that mark on my graph and say, okay, it got all the way back down to what I was calling my 0 point, or my 0 position after 10 seconds. So what do we get with that kind of graph? Well, you get something that starts to look like this. All right, so once again, this is a ball rolling backwards, rolling downhill as it goes backwards. Now, if we want to play that game with what does the slope represent, well, here, these are like, those tangent lines are close to 0. So I would say here at like 2, it's not, I don't know, maybe, still that velocity, it's maybe becoming a little negative there. So that's why I'm kind of writing these velocities, these meters per second, in my negative side. And then here at 4 seconds, it's a little bit steeper of a negative, a little bit steeper negative, a little bit steeper negative, or even steeper negative. So at 4 seconds, a little bit more negative, a little bit more negative, and then finally at the end, very, very negative. So really, what do we say the velocity is doing? Well, it's doing what that slope is doing. That slope is changing and going more and more negative. So we say our velocity gets more and more negative. And then really your only decision, these are the easiest ones, is to say, okay, your slope is delta V over delta T. This is a negative slope. And I don't know, just kind of guesstimating it, what is it, kind of like, I don't know, not quite all the way, down 1 over 1, I don't know, down 2 over 4, down 3 over 6, down 4 over 8, down 5 over 10. Really, yeah, we're just really going down 1 over 2 the whole time. And so this stays negative, and it would be the acceleration versus time graph would look like that. Now, a great way to check yourself, if you've kind of gone through this whole process, and remember, this acceleration, this change in velocity with respect to time, is all due to gravity. So if I'm calling the acceleration due to gravity negative, is down, yes. If you look at this picture here, this is going in the negative direction, and in fact down we would call the negative direction. And if down, gravity is always pulling it down. If down is your negative direction, acceleration due to gravity should also work out to be negative. All right. What are we going to do? Okay, same thing, just pushing marbles, Mr. Watterson. I understand if you're not watching. If you're still watching, great. But okay, let's push the marble. Actually, let's go back to bowling balls up a big, long driveway. Big roll, big push. That first oomph, you really pushed it up there. So let's say a couple seconds later, you gave it a good whirl, really tossed it. So it goes up the driveway, and after a couple of seconds, it's right at 30 meters. So here, after a couple of seconds, it's right close to 30 meters. Okay, now it's going to start to slow down. All right, as it starts to slow down, it's not going to go as far. So I don't know, let's say that's about, I don't know, a couple seconds later. So I'll put that mark on my graph. So here at 4 seconds, it's close to 40 meters away. So it's about there. Now it's really starting to slow down. So it gets about there, and let's say that's at about 6 seconds or so. So I'll put that mark on my graph. So it's 6 seconds. So again, these are times. At 6 seconds, it's really not much further, maybe just beyond that 40 mark. Now it's really going slow. So as it's really slowing down, hardly gets any further. Let's say that's at about 8 seconds or so. So at my 8 seconds, yeah, still not even quite to the top yet, not even quite to 50. And then finally at the very end, we can say, oh, okay, let's say here at the very end, after 10 seconds or so, it gets up to the top. Let's just have it stop there. So here at our very end, here at the very end at 10 seconds, it gets up to the top, right next to where that 50 mark is. So pushing the ball, bowling it, it's going to go bowling upwards up your driveway in the positive direction would look like that. And then it's the idea that you want to play these slope games again. So I love to think of it, okay, here at 2 seconds. What's that slope? Well, that's a positive slope. So I don't know, I'm just kind of guesstimating it close to like up 30 over 2. So just once again, it's just an estimate. Up 30 over 2, just around 15. If I tried to play that game here at 4, that's still a slope, but really it's, I don't know, it's becoming, that tangent line is becoming less positive. Or that tangent line, I don't know, what is that, like up 40 over 4 or so. Up 40 over 4, that's closer to like 10. Keep in mind, this is all based on that position graph. That's the change in meters over change in seconds. Change in position over change in time is what this is based on. If I were to look at it here at 6, leveling off a little bit, really not as steep, so I'm going to draw it a little less. Here at 8 seconds, it's still even less steep, so flattening out. Getting closer to my 0, getting closer to 0, and then really we said it stopped at the top. So if you kind of remember that picture of the ball going up, it really, we said it stopped up at the top. Yes, sorry, it was this one. We said it stopped up here. So if it stopped up at the top, up at 10 seconds, really I can say if it stopped, that is a 0 velocity. So what does that illustrate? It's going to be this thing. This velocity is going down until it reaches 0. Now, look at that line. What is the slope of that line? Well, I don't know. I'm just kind of guesstimating. It's a negative slope, but I don't know. What is it? It's like it goes down 15 over 10. Down 15 over 10 or so. So down 15 over 10 really keeps them all at about down 15, negative 15 over 10. Now, remember the trick with these is our accelerations on all of these, whether you're rolling it around on your driveway, rolling it around in class, throwing it up in the air, anything that you just let go and don't keep applying a force to, is going to accelerate due to gravity. So look at our picture here. This time going up is positive. The numbers get bigger as it climbs up there. So if up is positive, down must be our negative direction. And if down is negative, that also means our acceleration is also negative. And in fact, it is. All right. Let's try another one of these. Oh, last one. If you got this, this is the hardest one. This one, so really what I'm doing, I'm coming back to the multiple choice. So this is on our multiple choice, and this was that question 8. So a lot of people have been coming in to ask me about this one, and that was by design. I was really wanting you to, this one is tricky. And the thing is it has, once again, the ball's rolling, but that's not significant. What's important is how you define that direction to begin with. So let's come back to this. And oh, wait a minute, which question? Yeah, sorry, yes. So it was this one. Gosh darn it, it was this one. So let's come back to this question 8 here, and we'll take a peek at it. Here it is. Okay, so we've stacked up our books. We got this marble rolling up the ramp, and it slows down as it rolls up backwards. So same thing, kind of, you're bowling it up the hill. Oh, it moves the most space. Now this one I have set up where it's just like our lab tables. So our lab tables are about 2 meters. Or our ramps, there are tracks we can put on, are about 2 meters. So we'll start it there at the end, and we're pushing it up to the beginning. Okay, so that first push, it gets pretty far. So let's say here at 1 second. So if our time Time is measured in seconds. Here at 1 second, let's say we get it to about 1 meter. So it gets to that 1 meter mark in about 1 second. It gets to that 1 meter mark, in about 1 second. Then it starts to slow down. So it doesn't move as far. It's slowing down. So let's just kind of say here at 2 seconds. At 2 seconds, it only goes maybe to that 0.5 mark or so. And that's just kind of an estimate, but that's about halfway there. So, okay. Then it slows down even more. And really it's kind of real close to where it was. Let's say that's the 3-second mark. So at 3 seconds though, it's real close, maybe a little closer, but not much. It's right about where it was. And then finally I could say, okay, now it's really slowing down. Kind of gets up near the top. That's at about 4 seconds. So at about 4 seconds, maybe, kind of up near the top. But that's where the top is where our 0 mark tends to be. All right, so we get that kind of shape. And once again, this is the hardest one because this is slowing down as it goes backwards. And that's what you see on your position time graph. So keep in mind, these first ones that we've been doing have all been position. And that's just based on watching the thing move and marking where it is. Then use your slopes. Use your slopes to measure that velocity, or at least for this I'm just kind of estimating that velocity. Estimating that slope. Estimating that change in position over change in time. So here let's say up at the top, let's just look at it at 1 second. So that's a good one. Let's pick 1 second here. So what is this slope here at that 1 second? Well, that's severely negative actually. So I would say here at 1 second, my slope is negative. I don't know, what is it? Maybe that's like up 2 over 1 or close. I don't know, but it's very, very negative, very much in my negative range for that. Then if I look at 2, that point 2 there, okay, this is this tangent slope. It's still negative, but barely. It's getting closer to 0. It's barely negative at that point. The 3rd second, that's really, the way I've drawn it, that's almost flat there. So that is going to be really close to 0. And then same thing with this at 4 seconds. That's basically stopped moving. Stopped moving is 0 velocity. So what's so strange about this one is you throw that bowling ball up your driveway, you watch it slow down, you watch it stop, you watch the velocity increase until it stops. It's a very strange statement to say that your velocity is going up, but my velocity is going up as it approaches 0. So that's a strange one, but it's slowing down as it goes backwards. But the whole thing with this is now, okay, so what's my acceleration graph look like? Well, it is just as simple as saying, what's the slope here? Well, that is a positive value for slope. So my acceleration graph, positive slope, positive slope, positive slope. All of this is one line. It all has the same positive slope. Now, it's weird to say that your acceleration is positive as this thing slows down. But let's look at our picture. Okay, so what we have done in our picture is okay, so this thing's going up. So really what we've done in our picture, we said up. This thing's moving up, but that's negative. All right, 2, 1, 0, that's going backwards down our number line. So if up is negative, it's kind of a logic puzzle, I guess. If up's negative, then down must be positive. What does gravity do? Gravity always pulls it down. So this acceleration graph is purely a function of how you set up your measurements. How did you set your tape measure out there to start marking these positions to begin with? So once again, kind of coming back to that original question 8 on the multiple choice. This is coming up this way. It's saying it's rolling left. It's saying it's rolling negative that way. Then this must be positive. And once again, gravity, acceleration due to gravity, is always towards the ground. And in this case, towards the ground is the positive. It doesn't matter what way that marble's rolling. That marble could wassail back and forth, push it up, let it roll back down. It's asking you about this vector coming down towards the Earth, and that is defined as positive. I hope that helped with the motion graphs. I don't know, maybe a little sloppy, but I appreciate all your time. Thanks.